Hello and welcome back to Compiler Programming. Today I thought I'd do hopefully a quick video with a bit of an optimization topic. So there's nothing going to be really fancy, but there is something that I did want to share and talk about and describe a technique that sometimes can be quite useful. So I have this type, which is sort of a variant of either label, bytes of instruction, or special type of patches. And those are, I call them instructions. I'm not sure that's a good name for this really. But the point is, this is what I use to store the actual machine code bytes, if it is this thing. And also I mark up labels or some kind of patches that need to be done to the bytes for late resolution. And during the compilation of the program, you'll get a lot of these, like really a lot, especially for larger programs. For example, I have this test case that by default is disabled because it takes a bit too long to compile right now. And this is sort of what I'm working on with this change as well, is trying to make it slightly faster to compile. So this one, has maybe we can just say 1 million print statements. So it just calls our function calls. Let's put it this way. So it just calls print 1 million times. And even if it generates one instruction, which would be like the optimal, I'm not sure it actually does generate only one instruction, we would have at least 1 million of those structs stored somewhere, which means that every byte that we save here will save 1 megabyte of memory on the program. Now, right now we are sitting at around probably a gigabyte of memory for the whole compilation, so 1 megabyte might not seem too much, but firstly, we will not save 1 byte, we will probably save 16 or more like 8 or 12 per instruction or something like this. And yeah, this should be useful. Actually, in this case, we might not even save anything really for this particular test, but we should save on average. So here's what I want to do. The source range here, and these two fields, well, this is just a padding, but the source range itself, it's only really here for debugging purposes. Scope actually as well, but yeah, let's just focus on source range first, because scope will have the same idea, but it might be slightly harder to implement. So let's just focus on this one. The idea is we want to get rid of it, but we still need this information. So what is the idea then? Well, there is an interesting observation on the data of the program that most of the time you will actually have several instructions associated with a particular piece of code. Even like if I decide to keep it on line by line information, that would be a lot of instructions sometimes. And if I decide to keep it even on more detailed setup, like right now when we use it for every operator or stuff like this, then it's still going to be usually multiple instructions per thing. So one thing I could do is I could remove it from here, and instead I'm just going to add another variant of this struct, which will be source range, or let's call it location, and source range will become a field of this. Now I think we also will need that padding, so let's add it right away, and we'll say padding. The reason we do need the padding is because this particular struct is 12 bytes, and the whole union is 8 byte line, so we have these extra 4 bytes because 12 is not visible by 8 without an extra. So this will break code in a bunch of places, and we'll just have to slowly sort of go through all of this stuff and take care of it. Okay, so this is the interesting one. We have instruction for address, and this is actually where this source range is used. So how are we doing this? We have get function index from address, that's fine. And then we just scan the code in the search for the instruction. But in reality, we don't actually need the instruction. Well, sometimes we do need the instruction, but we kind of need this source range information. So in a sense, what we want to do is say source range out last source range, and save this when we need to. So maybe I need to describe what I'm doing a bit better. So previously we would have a setup as following in the array. So we'll have like, I don't know, move, call, whatever, add, and with each of it we'll have associated location that says it is this particular instruction will map to the source of the file from bytes 12 to byte 16, whatever. And this is, I don't know, from 18 to 21, and so on and so forth. But it also can happen that we'll have that call is mapping to the same original code, because we need to move some arguments to the function, and only then we can call it. So you can have like move, call, and all of them are actually mapping like this. So here you can see that like these first four are mapping to exactly the same range in the source file, and only the next one is different. So what I'm doing right now is I'm changing the format such that this goes into here, and then this will go into here. So now we don't have this kind of repeating information stored redundantly. But what it does mean that whenever we need to look up, for example, if we find that this is the instruction that we're interested in, if we need to figure out where it is stored in the source file, we need to sort of go back and find the associated source range. But in this thing, since we scan linearly from start to finish, we can do actually easier. We don't need to go back. We'll just say that we'll just sort of constantly store this. Actually, let's say, no, this is a pointer. So this is a pointer to const. That's fine. So here we'll say if instruction tag is instruction tag location, then it out source range is instruction location source range, and let me format slightly differently, something along these lines. Actually, this is I will make it optional. So if you pass in the pointer to this, then you will get the source range. If you don't pass the pointer, then this will become essentially a no-op in a processor, because it's going to be 100% predicted branch and it will not even affect the performance of this loop, which is kind of nice. And in here, I would say that we'll have source range, and we pass a pointer to it here, and then we can use it to print stuff. So I think this is the most complicated part of it. And then in here, we should be able to just pass zeros, because in here we are not interested in the source range. And this is called maybe out source range. And we need to have a pointer here. Okay, this is the tricky part. And right now, in order to check that we got this part right, what I can do is actually, same as before, push the source range information for every instruction. Just before we push any instruction, we'll just push source range information. And I think that's gonna be nice. Instruction add source location. Are we even using this function? We are not using this function, which is always nice to clean up. Okay, what else is going on? So push eagerly encoded assembly, right? So this is exactly where we would add the new thing, where we'd say instruction, tag location, and then here we'd say location, and then we would say, actually it's like this, location, source range is source range. And even just doing that, as you can see, will be very beneficial, because sometimes we will have 3 instructions just for a single machine code instruction, because we also have these patches for labels, and those no longer need to worry about source ranges. I think it is going to be a very good change, even if we don't change the calling code, which I will talk a bit later about. Okay, so we don't really need source ranges for labels at all, to be honest, but we might need to figure out where push label is defined. It is in function.h. Okay, push label, yeah. Location is not something that we are actually interested in anymore, so that's good. That actually fixed a bunch of issues. Let's see, what else do we have? Right, so here we do care about it. But not really. The reason I'm saying that we don't care here is because we call this function, and this function will push the source already. So here we don't care either. Here we have push label, that's okay. We need to remove this dummy range because it's not important anymore. More push label, and right. So here is actually the only place where we do care. So let's take care of it as well. Essentially, we just need to copy this small piece of code in here, and say that we have this source range. Oops. Something like this. Value undeclared. Wait, what was the source range? Marks source range. I see. Great. Now we need to skip over this stuff. In encoding, we are completely uninterested in this. Actually should be static, and that might help with performance as well. Okay, stack tag location and nothing to do. Great. And what else do we have? What is this? Command and proc. Yeah, here basically we say that location is also completely unimportant. Now another thing I could have done is I could have put it into a separate array and then kind of recorded the index from which this starts, which is more efficient probably, but it will be much more awkward to deal with, and I think I will defer this a bit more, because even just from doing this we should get a pretty chunky improvement. So let's see how we're doing. It builds now, and we can try to run the tests. There will be one test where we should see the location and we will know if we are doing it right. So yeah, this is exactly what we wanted to see. I mean, I can actually take this and I can apparently not go to here. My editor does not correctly parse this stuff. So let's try again. Yeah. So what this says here is that it's 3.2, and this is exactly the correct location. So this is, oh, here it says 3.2, so maybe I'm off by 1 in the character. Actually, no, character is here. No, this is, I think this is fine, but I need to check. Somewhere I might be off by 1 in line counting, but that's actually not the issue that we are having, because it was like this before. So yeah, this was a pretty successful refactor, and I'm pretty happy with it. Now we need to check what is the episode. I think I'm still on episode 177. So as you can see, there are already 2 episodes that are supposed to be 177. This one I completely screwed up the implementation, and this one was screwed up by OBS not working. So we'll have episode 177 again. Okay, so git add git commit -m episode 177. Optimize storage for instruction source ranges. Great. So this helps with like labels and patches not having to have source ranges, which are not useful anyway. Now the question is, as I said, a lot of the times multiple instructions map to the same location. The best way to see this probably will be if we look at something like arithmetic operation. So in here, this code can generate moves because it needs to get temporary stuff. There is more temporary variables if necessary, and then we return. And if we look at something even more complicated like division, there is even more instructions here. So we have 1, 2, I think it can be up to like 5 or 6 instructions, because for division the values need to be in the very specific registers and you need to get out of those specific registers, so it's just a bit of a mess. And this is where I would need to just sort of go through every function and do this process, where I would only insert one of these per bigger, for something that is visible in the source code from the user. And I don't want to do it all at once, so I don't want to break stuff. I want to transition separately. So what I will do is I will say that this will be no source range, and this thing will just not do this, and this one will do it, but then call the one source range. Pretty straightforward, right? Code block, source range, and assembly. Do you still compile? Yep, everything is great. And now, well, let's run the tests again and see those offsets. Just to verify, everything is still the same here. That's great. And now we can update our arithmetic, for example, division. And the reason, another reason I'm picking division is exactly because we'll see here if it's broken. If those values change, then I did something wrong. This is our division, and what we're gonna do is we're just gonna say, well, think over here is where we would insert it. Source range somewhere in here. It's called result range. And now we would just say no source range. And once I'm done with this, I will obviously rename it back. But for now, this allows me to, as I said, do this gradually and not worry about all kinds of weird things. Okay. We don't know what the code block is. That is very true. We'll need to put all this stuff in. Okay, so that should be, oops, that should be what I want. I have no idea how I got here. It's Alt Enter. Okay, great. So now what I actually wanted to do is I wanted to run the tests. Okay, let's see if we are still good. We are. We have this stuff. And now, as you could see, instead of one location for potentially 3 or 4 instructions, we only have 1, which is perfect. Now I will need to very painstakingly go through all the code, do this change, apply it, make sure it works, which is kind of boring, so I will not show it, but I hope you get the idea and I hope this is something useful. So again, whenever you have this sort of data where only parts of it are useful for some of your algorithms, it might be worth to separating it and putting it either into the same array, just with a different tag, and skipping it when it's not necessary. Like if all of your processing is just straight up scanning through arrays, that might be fine. If you want to be even more efficient, you can try to store it separately, but that would be more advanced, and maybe I will do it at some point if you can figure out how to do it yourself. So that's all I wanted to show, and thank you very much for watching, and hopefully see you next time.